Hey there, universe nerds! Have you ever wondered what happened in the very first moments after the Big Bang? Not millions of years later, not even seconds later, but the first fraction of a second. According to the theory of cosmic inflation, the universe expanded at a rate faster than the speed of light, blowing up from smaller than an atom to cosmic scales in less than a trillionth of a second. It sounds impossible, but this idea explains some of the biggest mysteries in cosmology. Today, let's dive into what cosmic inflation is, why scientists believe it, and what it means for the nature of the universe. To understand inflation, we first need to look at problems with the classic Big Bang model. For one, the horizon problem. Distant parts of the universe look almost identical in temperature, even though they should have been too far apart to exchange information or heat. Another is the flatness problem. The universe seems remarkably flat, balanced between open and closed, when any small deviation should have grown over time. Inflation solves both puzzles at once by stretching the early universe so fast that everything evened out, smoothing space like a perfectly ironed sheet. Inflation was first proposed in the early 1980s by physicists like Alan Guth and Andre Linde. They suggested that a special kind of energy field called the inflaton field drove this rapid expansion. For a brief instant, this field had negative pressure, pushing space to expand exponentially. When inflation ended, the energy of the field was released, filling the universe with hot radiation and matter, leading directly into the traditional Big Bang fireball we imagine today. The timescales involved are staggering. Inflation likely happened between 10 to the negative 36th and 10 to the negative 32nd seconds after the Big Bang. In that tiny sliver of time, the universe expanded by a factor of at least 10 to the 26th. That's like taking a grain of sand and blowing it up to the size of the Milky Way in an instant. Without inflation, we can't explain why the universe looks so smooth and uniform on large scales today. But how do we know inflation really happened? The evidence comes from the cosmic microwave background, the afterglow of the Big Bang. Tiny fluctuations in the CMB's temperature and polarization patterns match predictions made by inflation theory. These fluctuations are the seeds that grew into galaxies, stars, and clusters. Without inflation, the patterns in the CMB wouldn't look the way they do. In other words, the faint static left over from the Big Bang carries an echo of inflation itself. Inflation also predicts something else: gravitational waves from the earliest universe. These would be ripples in spacetime, imprinted in the CMB as a subtle polarization pattern. Detecting them has become one of the holy grails of cosmology. While experiments like BICEP 2 initially claimed detection in 2014, later analysis showed the signal was mostly galactic dust. But the search continues, and if we confirm these primordial waves, it would be the smoking gun for inflation. Of course, not everyone agrees inflation is the final answer. Some alternative theories suggest the universe may have bounced from a previous collapse, or that other mechanisms could explain the horizon and flatness problems. Inflation works beautifully, but it also raises new questions, like what exactly the inflaton field is, and whether it connects to deeper physics like string theory. Science thrives on these open mysteries, and inflation keeps cosmologists busy debating. One of the most intriguing consequences of inflation is the idea of a multiverse. If inflation happened once, it may still be happening in other regions of space beyond our observable universe. Our universe could just be one bubble in a vast multiverse, each bubble with different physical laws. This is speculative, but it's a natural outcome of some versions of inflation, making it one of the most exciting ideas in modern science. Even if we never see beyond our own cosmic horizon, inflation reshaped how we think about the universe. It shows that the largest structures in the cosmos, galaxies, clusters, superclusters, were seeded by quantum fluctuations stretched to cosmic scales. The tiniest physics gave rise to the biggest structures. The story of inflation links the quantum and the cosmic, bridging worlds usually thought to be separate. So what is cosmic inflation? It's the theory that the universe expanded faster than light in its first instant, smoothing space, seeding galaxies, and shaping everything we see today. It explains why the universe looks the way it does and points to possibilities beyond our horizon. Next time you look up at the stars, remember, they all trace back not just to the Big Bang, but to the wild inflationary moment when the universe went from microscopic to cosmic in the blink of an eye.